Hi, I'm Chris from Team Thermos. We are planning on building a small-scale power plant that incorporates a black body heating a working fluid. We're currently testing a small evacuated tube demo unit. We are taking readings with individual tubes in order to generate a transfer function. We plan on comparing this data to a small plot of blacktop in which we have encased a copper tube to check the viability of our design.
So far, we have taken the input temperature from the city's water as it flows through our evacuated tube design. We can see that the temperature of the water changing over a half an hour of samples, where our sample time is set just over 1 second. You can see how the change in water temperature from the input and output of the system compared to the ambient temperature. So we'll use this in future designs. What we want to do is determine how scalable our design is by comparing, we have 4 possible tubes that we could process the water through. So we'll try processing the water through 1 tube, 2 tubes, 3 tubes, and 4 tubes to see how scalable this design can be.
Hi everyone, this is John. I'm going to walk you through some of the simulation updates that we have. This is the DW simulation software on your screen, and this is a very bare bones model of our organic Rankine cycle. This will be our fluid, our pump, our boiler, and our condenser, and there's our turbine. From this, pretty much we can set up our mass flow rate and see, as we increase that, the kind of wattage that we'd expect to see on the outtake. And then we can also determine how much energy we need to put in via the heater, be it that through the asphalt or the solar evacuated tubes. So right now we're sitting around 16. Our best guess is we're going to need to put into 15 to 20 of kilowatts of heat energy in order to get our desired 1 kilowatt out of the turbine, at least with the current expected mass flow rate. This is the MATLAB model. Right now, it's kind of nascent development. This package comes with the Simscape software available through Simulink. And going forward, it'll be my job to kind of reverse engineer a little more bare bones simulation for our organic Rankine cycle. For example, we won't be using a steam reheater, and most likely we won't be using a feed water preheater. So it'll be a little tear down, a little bit of rebuild, but it gives us a good place to start, and can't wait to start inputting data.
Hello, I'm Michelle, and I am going to be designing the both side pump driver for our pump. Currently, I have this built in LT Spice, and we're going to run some simulations to see what type of pump we can use to get out get the correct flow through the pump fluid for our feedback system, and then we will have to do that. I have just received all of the pieces to build this hardware, and I will be keeping one of them here and one of them to Chris, so Chris can do the more testing with an actual pump through the system, so we have an actual flow rate instead of trying to estimate it right now for our data.
We should be able to generate approximately a kilowatt of electricity. Here is a simulation of 3 of our solar panels put together using water, in which we are able to heat water to the desired temperature. We also have an additional burner for those days in which there isn't quite enough power. This is modeled in my location, which is March Air Force Base and in Southern California. We plan on using this exact simulation from TSOL to use for our black body. Our black body will replace the solar collector, and we should be able to also see how well our system works.